All right, for advanced math, we're going to continue with limits. So, going back to where we talked about last class, when it comes to a limit, okay, we learned a technique to do this, and we did direct substitution. Okay, we did direct substitution. So, let me give you an example of that. So, if I have the limit as x approaches 4 for the function x minus 1 all over x squared plus 2x plus 3. Well, to do this, when I do direct substitution, I just go ahead and plug this in to all the x values and see what it comes out to. So if I get this, I get 4 minus 1 all over 4 squared plus 2 times 4 plus 3. And if I do this, I get 3 over 16 plus 8 plus 3. Okay. And so I get adding these up, I get 3 over 11 equals 3 over 27. Okay. Direct substitution, pretty straightforward. The algebra is very simple. You just plug in the x you're approaching into the function and see if you get an answer. Okay. Well, this is great. Well, the problem is with this, it doesn't always work. Okay, and so what happens is we start to get functions that if you do this at the very beginning, it comes out indeterminate. So let me give you an example. So if I gave you a function like, what is the limit as x approaches 9 for 9 minus x all over x squared minus 81? So if I go ahead and try my direct substitution, right, just like we learned how to do, it would be 9 minus 9 all over 9 squared minus 81, and then I get 0 over 81 minus 81, and then I get 0 over 81. So this is kind of weird. The biggest issue is that I have a 0 in the denominator. Okay. So I don't really know what's going on in terms of a limit, so this is not going to work by simply doing direct substitution by plugging in the 9. So it doesn't mean that it doesn't have a limit, it just means I can't use direct substitution off the bat. And so we're going to use some basic algebra here to kind of get around this. So what we're going to do is we're going to try to simplify this function so that when we do plug in the 9, we don't get this 0 in the denominator. Okay, so I'm going to take this function, and what I'm going to do is I'm going to factor it. So kind of coming down here, all right, I'm going to say the limit, all right, and then I'm going to leave the top alone for now, and the bottom is going to be a difference of squares. Okay, and so I'm looking to reduce something. Hopefully everything crosses out. So these are pretty close. So what I'm going to have to do here, is factor a -1 out of the numerator, and it leaves me with -9 plus a positive x all over x minus 9, x plus 9. So now these reduce. Now be careful because I still got this negative up here. So what I now have is the limit as x approaches 9 for -1 over x plus 9. Now if I plug in my 9, I'm going to get -1 over 9 plus 9. And so my limit is -1 over 18. So what is the strategy? The first thing I want to do is always try to just plug it in and use my direct substitution. If that doesn't work, then I try to factor and manipulate the function and simplify it and see if I can plug it in again at the end. Okay, so let's keep going with this. So if I say, what is the limit as x approaches -1 for x squared plus 6x plus 5 all over x plus 1. So first things first, try to do my direct substitution. So what I'm going to do is I'm going to plug in a -1 right there, and it's going to give me 0. -1 plus 1 is 0, so it's not going to work. So what I'm going to have to do is factor it and see if I can get it to simplify. So the limit approaches -1. The top is a trinomial. Okay, and I ask myself what multiplies to 5 and adds to 6. And I get x plus 1 and x plus 5. So now I can reduce these two, and I'm left with the limit as x approaches -1 for just x plus 5. Now I'll go ahead and do my direct substitution. All right, and my answer is positive 4. Okay. Positive 4. So what happens, there can be some kind of weird factoring and different things. So let's kind of look at a couple of different scenarios that come up that kind of throw people off. Here's the first one that gets people. What is the limit as x approaches -4 for a to the third plus 64 all over a plus 4? So same thing, try to do my direct substitution. If I plug it into the denominator, I get a 0. So I cannot just plug that in, right? So I can't divide by 0, so I'm going to have to do some factoring. If you notice, the top is a sum of cubes, right? So this is where we had a formula. I kind of told you a little, we used to call this SOAP, or same, opposite, always positive. So remember, it's going to be a binomial times a trinomial. The trinomial will not be factorable. So it's going to be the same sign, the opposite sign, always positive. Then the first term is the cube root of the first term, the cube root of the last term. It's this term squared, the product of those two, and then the last one squared. Okay. So now you can see my a plus 4's cross off. Okay. So now I have the limit as x approaches -4 for just a squared minus 40. -4a plus 16, and sorry, this should be as a approaches -4. As a approaches -4. So plug that in with my direct substitution. I'm going to get -4 squared, -4 times -4 plus 16. So I got what, 3 16s here? 16 plus 16 plus 16, which I believe is 48. Okay. Let's do 2 more examples, and these are the 2 that tend to throw people off the most. That we have to do, the manipulation is a little bit different. We're going to actually kind of do the opposite of factoring. We're actually going to multiply by something. So looking at something like this, what is the limit as x approaches 0 for the function the square root of 7 minus x minus the square root of 7 all over x? Okay, so what basically I'm going to do is plug in my direct substitution, plug in my 0, then I get a 0 in the denominator, so I know I can't just do that. So now I got to manipulate this thing. So what I'm going to do here, this has radicals, right? And so basically this thing has kind of been rationalized, like they got the radicals out of the denominator. So I'm going to kind of reverse that process. And if you remember, we did this with a couple other things, but it kind of popped up. But if you can remember here, what we're going to do is we're going to multiply by the conjugate. Okay, so the conjugate, and we're going to use the conjugate of the numerator. And that's when you have the same first term, the same second term, but the sign in the middle is going to be different. So the conjugate that I'm going to multiply by is going to be plus. Okay, so I'm going to multiply by the conjugate. So up top, these two have to be FOILed together, right? Binomial distribution. So if I multiply the first two together, I get the limit as x approaches 0, and I'm going to get just 7 minus x. multiply the back two, plus the square root of 7 times this, multiply the front two, and if you remember, conjugates will get you a set of opposites, and that's basically what we're trying to get to here because they'll cross out. So you can see there's a positive one and there's a negative one, and the last one is going to be a negative times a positive, which is minus 7. Okay, down below, I'm just going to leave it and not actually multiply it, because I'm hoping something is going to reduce. Okay, so if you look at it, here's a positive root 7 times the quantity square root of 7 minus x, and there's a negative one, so those add up to 0. A positive 7 and a negative 7 also add up to 0. Okay. And so what I'm basically left with is a negative x. So I got the limit as x approaches 0 of negative x all over x times the quantity of this. Okay, so these reduce, and I get the limit as x approaches 0 for negative 1 all over square root of that plus the square root of that. Now I'll go ahead and plug in my 0, right? And so if I do that, I get negative 1 all over the square root of 7 minus 0 plus the square root of 7. Just kind of working my way down here. Square root of 7 plus the square root of 7. And this equals negative 1 over 2 square root of 7. So what I basically did by multiplying by the conjugate is I unrationalized it and put the radicals in the bottom. So you can rationalize this by multiplying by root 7 with root 7, but I'm just going to leave it in this form. It's not a big deal when you get to calculus. Typically, you don't have to rationalize stuff. Sometimes you do, not always. All right, one last example. And the same kind of issue here. So what is the limit as x approaches 0 for 1 over x minus 8 plus 1 over 8 all over x? So same thing, I'm going to plug in my 0. If I plug it in right there, I'm okay. But if I plug it in right here, I'm going to have a problem. So that's not going to work. So in this case, what I'm going to do is I'm still going to multiply to the top and the bottom. But I don't have square root, so I'm not going to use a conjugate. What I'm basically going to do is clear this top fraction. So I'm going to multiply by the common denominator, which is 8 times this. But I have to do it to the top and the bottom, right? Because I technically have to be multiplying by 1. If not, I'm going to change the value of the fraction. So if you kind of look at it here, it's basically like if I was to multiply this, this would get distributed in. And this is only going to go to the top, because think of this as like being over 1. Okay, and then this bottom, or these two, are going to get multiplied together. So what I'm going to be left with is the limit as x approaches 0 for 8 over x minus 8 all over x minus 8. Distributing it to that first one, distribute it to the second one. And in the bottom, I'm going to wait to distribute it because I'm going to hope something reduces. Okay, so now I basically multiplied by 1 by doing it to the top and the bottom, but I was really trying to clear these fractions. So that reduces and that reduces. So I get the limit as x approaches 0 for 8 plus x minus 8. There's nothing to distribute anymore. All over 8x times x minus 8. So I got a negative 8 and a positive 8. That adds up to 0. So I'm basically left with, so those add up to 0. I have an x right here. All I'm left with is an x. These are all being multiplied right here, so I can cross off that x. Lost my 0 there. And now what I have is the limit as x approaches 0 for, I'm dividing here, so I'm left with a 1 on top. And then 8 times x minus 8. Now I'm going to go ahead and plug that in. So I'm going to get 1 over 8 times 0 minus 8. And then I'm going to get 1 over negative 64 is my limit as I approach 0.